Welcome 6th grade math students. We are currently working on Chapter 3, learning to multiply and divide fractions and decimals. So moving ahead to lesson 3.3 today, we're going to talk specifically about dividing decimals. What I have in front of you is a math breaker map. This is a thinking map to kind of help me decode division of decimals using some basic steps. So I'm going to kind of enlarge this for us and see if this will help us through, again, the operation of dividing decimals. If you take a look at your math breaker map, this can also be found in the back of your notes packet. This is really just a way of organizing our thinking. So first it says write the problem, and then it asks, is the divisor a whole number? And we'll have to move through this flow chart or this math breaker map depending on what our answer to that question is. So the first thing I'm going to look at is a problem of 105, and we're going to divide it by 5. So just thinking for a quick minute, it asks me, is the divisor, and this is really important, the divisor, or notice here the second number, is the second number or the divisor a whole number? Well, if you notice, I don't see a decimal in this 5. So we would say in this situation, yes. So following my math breaker map, I would follow this arrow down and I would see it says, go ahead and divide. Be sure to bring up the decimal point into the quotient if needed. So this is a division that we've seen before in the past. I would put my dividend inside the division symbol here, and I would divide by a divisor of 5. These are both whole numbers, and they tell me to bring my decimal straight up. So really, I'm not seeing a decimal in these numbers, and I'm not going to worry about that too much as long as my division works out nicely. So I'm going to say, does 5 go into 1? Taking this just in parts, and the answer would be no. So I show that with a placeholder. Next, I would say, does 5 go into 10? I take the first 2 digits, taking a larger part of this whole number inside. And the answer is yes, it goes in there twice, because 2 times 5 is 10. When we subtract, there's nothing left. And I know things are going well because my leftovers of 0 are smaller than my divisor of 5. Next, I can bring down the next place value. And in this case, I know 5 goes into 5 one time. So I'll put 1 in my quotient, and 1 times 5 gets me the 5 I was looking for. When I subtract, I'm left with nothing. A final answer to this problem is 21. Oh, a 6th grader's favorite number. So this one's not too scary because, again, we were using a whole number divided by a whole number. But as you know, today our goal is to divide some decimals. So I'm going to clear this problem, and we're going to try again. But this time we're going to mix it up a little bit. What happens if my dividend is a decimal? What happens if my dividend is something like 23 and 5/10? And I want to divide it this time by, say, 0 and 5/10. Well, in this situation, I happen to have a decimal in both my dividend and my divisor. But the real question says, is the divisor, this is the important one, a whole number? Well, the divisor is always the second one. He's always the supervisor. He's always overlooking. So right here he is, the divisor. And is it a whole number? The answer would be no. You notice there's a decimal sitting here between the 0 and the 5. This actually shows 5/10. So I cannot say yes. In this situation, I'm going to follow my math breaker map and follow the no path. So step 1. Make the divisor a whole number by hopping the decimal to the back of the number. So if I look over here at my hawk hints in my example off to the side, I notice that when the divisor has one number behind it, we make one hop. Now, it's actually kind of important to me that you understand we're multiplying by 10 to do that. So a power of 10 makes the number look larger. It moves that decimal one place value to the right. So that's exactly what I need to do for this problem. I need to move my divisor one place value to the right. My decimal and my divisor, one place value to the right. And when I do that, I no longer have 5/10. I currently have 5 wholes. Now the only way this is going to work, if you remember, is we have to keep things fair. So we keep things fair in fractions, we keep things fair in equations. I also have to keep things fair in this division problem. So if I decide to do that to the divisor, or my second number here, in a moment, this hawk is going to walk me through the steps of doing that to the dividend also. Let's see if I can scroll there for us. So this is what I see next. Step 1, make the divisor a whole number by hopping the decimal to the back of the number. We did that. So currently I have changed from 0 and 5/10 into, oops, well, I guess I could have that 0 there, it doesn't hurt much, into 5 wholes. The question is, how many hops did we make? Well, we actually multiplied by 10, or 10 to the first power, or we could say we just hopped once to the right, 1 hop. Well, we're ready to follow our math breaker map on. I'm looking for step 2. This is step 1, I'm all set. Next I need to fast forward to step 2. Let's see what it says down below. It says find the decimal point in your dividend and hop that decimal the same number, this is pretty important, isn't it, of hops as the divisor. So the same number of hops. The problem is I don't remember what number I gave us. So let me go up and peek, 23 5/10. So in this situation, I'm going to go from 23 5/10, and remember, I'm going to hop 1 time to the right because that's what my divisor said to do. And I'm going to now end up with 235. This almost looks like a whole number that we had to start with, the last problem. So I have 235 now, and I'm going to divide it by that 5 that I found just a minute ago. Step 3 tells me follow the path this way, and we're actually going to do a rewrite. So that wasn't 23 5/10 anymore. I've changed it to 235 because I multiplied by 10. I also did the same thing with my divisor. In fact, my divisor kind of gave me that rule. My divisor said how many hops or jumps or how many multiples of 10 to use. Well, now it says go ahead and divide like always, and make sure you bring your decimal into your answer or your quotient if needed. So the first number, the 235, becomes my dividend. The 5 is my divisor. He's overlooking or supervising everything. And we're going to figure out how many times 5 goes into this. So 5 does not go into 2. I'm going to show you with a 0 or a placeholder here, but 5 does go into 23. How many times? Hopefully you say 4 times. 4 times 5 is 20. And I'm handling this like a typical long division at this point. When I subtract, I'm left with 3, and I know things are going really well. I always check. I check to make sure that my leftover 3 is smaller than my divisor, and it is. I'm ready to bring down the next place value, and 5 goes into 35 7 times. Well, because 7 times 5 is 35. When I subtract, there's nothing more left over. Oh, we've got Cortana helping us out now. Go away, Cortana, somehow. There we go. And it looks like I got a final answer of 47. So this math breaker map is really intended to help us walk through the steps of how to move those decimals, how many hops to make. And I might emphasize right here, whatever I do to my divisor, I have to do to my dividend. I oftentimes in class call this Simon Says, and I believe we got an answer of 47 down below. Final answer. Okay, so we've seen 2 answers that end up being whole numbers, but will that always be the case? Unfortunately, absolutely not. Or I guess in an interesting way, absolutely not. So let's go ahead and try something different. I'm going to give you something like 30 8/10. And in this case, we're going to divide by 0 and 40 hundredths. Let's hope that this works out because I'm just making things up at this point. So, again, we're going to follow our math map. We're going to think about how many decimal places we see, and that's going to help us determine how many hops or multiples of 10 to use. So, following the rules, check the divisor first. Oh, my divisor, it has a decimal. So the question is, it's not a whole number. No, it's not. So I'm going to have to go ahead and follow step 1. I'm going to have to start hopping the decimal, also known as multiplying by tens. So if I hop the decimal, I'm going to have to move how many hops? 1, 2. Looks like it's going to take 2 hops for 2 groups of 10, or multiplying by 100. I want to rewrite this as 40. The divisor sets the rule. Simon Says jump twice to the right, and that's what I need to do. So on my dividend, I follow the same rule. Remember, it said the same number of hops for step 2. So starting at my decimal and my dividend, I hop once, twice to the right. And this would be my new decimal destination. Easy for me to say. I kind of need to do a rewrite step here, don't I? In fact, I need to clean this up a little bit, and I need to make sure to put a placeholder here in a second. So if I were to rewrite this, and again, I'm not really scrolling down into my math map to show you each step along the way. I handled a couple steps right in this first box. In step 3, I now have 3,080, and I'm dividing by not 4 tenths and not 40 hundredths, but 40. I made it a whole number. We're going to go ahead and set up this division. We're going to hope that things go well. And I'm just going to try to show some work for us over here. I think there's there's enough space to make this work right now. Divided by 40. Well, I say to myself, does 40 go into 3? And the answer is no. But does it go into 30? The answer is no again. But I bet it goes into 308. And the question is, how many times? Well, I know 4 times 7 gets me 28. And that seems pretty close to this 30 out front that I want. So if I try a 7 times 40 shouldn't be 28. It should be 280. And that's perfect because it gets me close enough, I think. 8 take away 0 is 8. And here a little bit of a regroup. 10 take away 8 is 2. Well, 28 is definitely smaller than my divisor. Things are going well. I'll bring down the next place value. And I currently have 280. I want to divide that by 40, and this is perfect because a moment ago, I figured out that 7 times 40 got me exactly 280. Must be another 7 in my quotient. You'd go ahead and you'd multiply and subtract, and you would check to see that things are going well, and they are. Our final answer here ends up being 77. All right, again, I didn't end up with a decimal in my answer. So I'm going to dig into our notes, and I'm going to find an example from there that might make us think a little bit more. So again, we're always going to change our divisor to a whole number. And however many hops or multiples of 10 we use the same rule with our dividend. So grabbing my notes here quickly. Today we had a problem that was something like this in our notes. We had a whole number, but then we had to divide by something like 0 and 5/10. Well, this one's interesting because I have a whole number and a decimal. Not both are whole numbers and not both are decimals. I have one of each. So the rule says check your divisor first. See if it's a whole number. Well, divisor, here you are. The second number is always my divisor, and the answer is no. It is not a decimal. So I'm going to have to follow step 1, which says, make the divisor a whole number by hopping the decimal to the back of the number. Oh, I can handle that. I started the decimal, and how many hops or multiples of 10 should I use? Just 1. This is like saying, I'm going to take 5/10 times 10, and it's going to become a whole number. Here's my new decimal location. But if you follow this ahead to step 2, what does it tell you to do with your dividend? It tells you to do the same great thing. So I start with my decimal and my dividend, which actually I don't see. This could be a problem. Well, if you think back to the invisible math rules we talked about in class, if you remember, all whole numbers do have a decimal. They just usually don't show. That decimal is always located at the back. So starting here with a whole number of 2, my decimal needs to hop 1 time to the right. It's just like Simon says. My divisor, my Simon, my Schumann here said hop once to the right. So you want to win the game, you have to hop once to the right. I do need a placeholder in here when I do a rewrite step, and this is really the same problem as 20 divided by 5. Well, I know that 5 goes into 24 times. I end up getting a pretty decent answer pretty quickly. All right, so we've tried a couple combinations. I think it could get more interesting than this. So I'm going to try to find one that I think might make us think a little bit more about where that decimal is going to land in my answer. The next one that I'll give you for your notes practice today is 0 and 72 hundredths divided by 0 and 3/10. Oh, decimal in both again. But this one gets a little more interesting because I noticed the divisor sets the rule, and these decimals are kind of located in different places. This one gives me hundredths, and this one just gives me tenths. Well, the divisor is the one that matters. The second number, he's the boss. And in this case, he says, we better hop once to the right. We're trying to turn our divisor into a whole number. Well, whatever you do to one number, you must do to the other. We try to keep it fair. So if Simon says hop once to the right, guess what you should do? Hop once to the right. You want to win the game. If I were to do a rewrite step here for you, now I have 7 and 2/10. And I'm still dividing, but I'm dividing by 3. Now my divisor is a whole number. I'm ready to set this one up. So this really would be down there in box 3. This would be another place to show your work. Or really you can follow the steps and just show it in another location. So you can use the same steps on lined paper, you can use the same steps in your notes, you can use the same steps on your homework. I'm going to take that 72 and, oops, I did that wrong already. I'm going to try to back up a minute. It's not 72, it's 7 and 2/10. And I'm going to show you that it's my dividend. The dividend always dives in. And I'm going to be dividing it by 3. I've rewritten it and multiplied both numbers by 10. so I could have a whole number. Now this is where it's unique. Before, we always had a whole number on our dividend. This doesn't look like a whole number to me. In fact, there's a decimal located here, which gives me 7 wholes and 2/10. I want to move this decimal straight into my quotient to get an accurate answer. So whenever you have a decimal appearing in your dividend, it moves straight up now, so we can be accurate. Well, 3 does go into 7. It goes in there twice. So I'm going to divide like I always do. And I know 2 times 3 is 6. When I subtract, I'm left with 1. I really ignore this decimal. It's already in position in my answer. So I just bring down the next place value, and I say 3 goes into 12 4 times. But notice, because I brought this 2 down, that 4 aligns in the same column. It actually lands in the tens place. And 4 times 3 is, in fact, 12. When I'm done, there's nothing remaining. A final answer for this problem is 2 4/10, or 2.4, just so that you're writing it accurately. Have that decimal in the middle. I, again, want you to use this math map to help you anytime you see a decimal in your dividend. And the dividend is always that second number. So however many hops that dividend, that Schumann, that Simon tells you to make, you also do the same in your dividend. The next thing I'm going to flip to here is our actual notes packet. And I'm going to zoom through some examples there, so hopefully you have a few more to go on. Unfortunately, I'm not seeing them real quickly. This is good for a video, isn't it? There we go. If you move into your notes packet, we're actually on page 8. So I'll try to skip there quickly for us. Page 8 of your notes packet. The first problem looks like this, and it talks about Jamie. There's a word problem. So sometimes our decimal division skills can help us solve a word problem as well. It says divide a whole number by a decimal with 1 decimal place. That's what we're going to do here. Jamie and his friend live 1 mile apart on the same street. Each block on the street is 0 2/10 miles long. How many blocks apart do the 2 friends live? If you were in class today, we took a quick visual approach. We made a quick bar model, and we said that bar represents the 1 mile of distance. And then we said that this is broken into. It says that it's each block on this street is 2/10 of a mile. So I need to break this into 2/10 and another 2/10 and another 2/10. But I really encourage you to do this ... to be continued, because I don't know about you, but I absolutely did not turn this into a perfectly long mile. In fact, I probably would have run out of space trying. So I'm just going to set this up so that I visualize I'm starting with a total of 1, and I'm dividing it into little tiny pieces of 2/10 each. Well, I want you to think back to that math map. What did it tell me to do? Check the divisor first. Simon says hop once to the right. Well, if you hop once to the right, because Simon says, you need to do that also with the dividend. So hopping once to the right, this 1 was a whole number with a decimal behind it. It moves 1 hop or multiplies by 10, and actually I end up getting a new problem, 10 divided by 2. I'm guessing without setting this up with some long division, you know what number times 2 will get me 10 working backwards? It would be 5. And we also need to make sure we're labeling. When they give me words, we give them words back. So how many blocks? 5 blocks. Sometimes in class I will tell you that I show this Simon Says approach right within the problem. So I might do something along this line. I always like to show that decimal in my whole number, so the decimal in the 1 is at the back. Now Simon, he's like the supervisor. He's also called the divisor. He's on the outside and he says, hey, hop once to the right. And if he says it, you do it. Hopping once to the right. Remember, we bring our decimal straight up in this situation, and you still get the same great problem. You still have 10 divided by 2. You'll still get the same answer of 5 blocks. This problem should also be in your notes packet. And notice, this time I don't have a word problem, but I'm still going to take a whole number, this 1, and divide by 5/10. So if we were to set it up, not even worrying about decimals for a quick minute, we would start with something like this. That 5/10 is my divisor, and the 1 is my dividend. It goes on the inside. Now you might say to yourself, where's the decimal in 1? And it's always important to know whole numbers have a decimal at the back. So who's the divisor? Who's the supervisor? Who's the Schumann or the Simon that says what to do? Well, in this case, 5/10 is the divisor. He tells us to hop one place to the right. That's also the same as multiplying this number by 10. Well, if I do that to the outside, I better do that to the inside. We keep it fair in our division. So I need to show a placeholder here, and remember that decimal gets to move straight up now. Kind of like Paula Abdul if you lived through the 80s and 90s, I guess. So the question is, how many times does 5 go into 10? This might be the same as something that we just tried in our math map a minute ago. Well, 5 does not go into 1, but it does go into 10 twice. And when I multiply, 2 times 5 is 10, and when I subtract, there's nothing remaining. A final answer in this situation is just 2. And then they give us some more challenging numbers. And in fact, in this case, it says that I'm going to divide a whole number by hundredths. If I'm dividing by hundredths, it's going to require more decimal hops, isn't it? Or multiplying by a greater value of 10. So instead of multiplying by just one group of 10, I might have to multiply by 2 groups of 10, also known as 100. Let's go ahead and set this up. And before I do, I want to point something out that students always panic about. Each year I have a couple students that are like, oh dear, Mrs. Schumann. Oops, my arrow isn't really aligned here, but I'm trying. Oh dear, Mrs. Schumann, we have 2 decimals. Which one matters? I want you to know there's only one decimal in this problem. Just one. One of these decimals is the real deal, and the other one is actually called punctuation. It belongs to the sentence. Oh, when you see it that way, hopefully you'd say, this point at the back is called a period. This point between 0 and 1, that's my decimal. Let's go ahead and try setting up our division. So I'll remember my first number dives in. He dives in because he's the dividend. There's 96. And on the outside I have 0 and 12 hundredths. Make sure that decimal is showing if you haven't done your math map yet. We want to make sure we remember the same number of hops and make sure we keep track of it in the problem. Well, the question is, where's the decimal 96? I might need to see it. Well, all whole numbers have a decimal at the back. If that's the case, I'm ready to tune into my math map steps, which always say check the divisor first. What does he tell you to do? Well, Schumann would say hop twice to the right. Maybe Simon would say it. Maybe just your math map would tell you. We want to make this divisor a whole number. So with 2 hops to the right, I really multiplied that number by 100. Well, that's only fair if you do the same thing to the inside number. So how many hops do we make? 2. Which direction? To the right. And we have to make sure we move our decimal place that many places. Our decimal point that many places. Let's move our decimal straight into our quotient. And things are looking a little funny for a moment. Maybe you notice we need some placeholders here. So where I made these 2 hops, usually you don't jump in thin air unless you're Michael Jordan. And I would probably rather see some placeholders here, just so that I can keep things aligned. What I've really done is I've rewritten this problem. I now have 12 divided into 9,600. And a decimal at the back in case I need to see it. Let's go ahead and try this division. Does 12 go into 9? The answer is no. Does 12 go into 96? The answer is yes. Maybe you notice that 8 times 12 is actually 96. You could check your multiplication chart, or you could just try it out. When I subtract, there's nothing left, but there are some numbers to bring down. So how many times does 12 go into 0? Or what times 12 gets me 0? The answer is 0. Now I could do it again. There's another placeholder to bring down. And you would say, well, how many times does 12 go into this 0? And the answer would still be 0. There are no other digits to account for. You took me all the way back here to the decimal. I actually have a final answer of 800. So here, or with a quick cleanup step, we would just show 800 as a final answer. This one's very similar because, again, we have a whole number divided by a number in the hundredths place. Now do be careful, only one of these is a decimal. So if this says find 98 divided by 14 hundredths, I'm guessing it's talking about a sentence format. This last point is actually a period. This is the decimal we're going to have to tune into. You can tell my pens are slightly not aligned, so I'm kind of fighting with them. If you were to just follow your math map, how many hops would the divisor have to take? Well, Simon would say hop twice to the right. And whatever Simon says, you must do. So hop twice to the right with 98. When I do that, I'm going to end up with a brand new problem. I'm going to have 14 as a whole number and 9,800 as my dividend. Remember, that decimal is moved 2 places to the back. It started here and hopped. So at the back of this number, I might move this decimal straight into my quotient, and I'm ready to divide. Let's go ahead and fast forward to another slide here and see what else we have. Here they're showing us that we can consider dividing tenths by tenths, and we could use a number line to do that. So if they tell me to find 8 tenths divided by 2 tenths, they're saying that on this number line I could start from 0 and get all the way to 8 tenths. And I want to figure out how many little 2 tenths would be in here. Again, remember that last mark is really a period and it's not my decimal. So I'm thinking to myself, counting by 2 sounds familiar. 2, 4, 6, 8. Oh, so I really need to show 2, 4, 6. I need to show 3 hops along the way, it looks like, or 3, I guess I should say separations, to make 4 intervals. Would this work? The first stop would be called 0 and 2 tenths. The next hop or stop would be called 0 and 4 tenths. If I count by another 2 tenths, I'd be at 0 and 6 tenths. And then really what I'm saying to you is I'm trying to figure out how many intervals that takes. It required 1, 2, 3, 4 intervals. Each small interval represents what I'm counting by, the 0 and 2 tenths. And there are actually 4, I could count them, 1, 2, 3, 4 intervals when I'm done. And so the answer must be 4. It's actually how many hops or jumps we had to make of 2 tenths to get to the end. Here's another number line problem. And again, we're thinking of taking tenths divided by tenths. I could show that by putting my destination at the end. So 0 and 9 tenths, that's what I want to start with. That's kind of what I'm trying to get to, counting by 3 tenths. I'm trying to figure out how many groups of 3 tenths belong in here. Well, I'm thinking 3, 6, 9. And if I started with 0, that would be 1, 2, 3 hops, or 3 intervals. I need to draw 2 lines. So if you hold up 3 fingers, you can see that there are 2 separations in between. I need to draw 2 lines to get 1, 2, 3 equal intervals. From 0 to the first stop would be 0 and 3 tenths. And I'm going to add on another 3 tenths. So 3 tenths plus 3 tenths gets me 6 tenths. And if I add another 3 tenths, I'd be at 9 tenths. How many hops or intervals did that take? 1, 2, 3. I think I'm ready to answer the question. Each small interval, each little hop was worth how much? 0 and 3 tenths. And there are how many intervals or hops? A total of 3 intervals or hops. So the number of intervals I get is actually my answer, 3. I could break 9 tenths into 3 equal parts of 3 tenths each. There are a couple ways to approach this next problem, and I'll show you both, and after that I think we'll stop there and hope that you have enough notes practice to get you going on your assignment. So we're given a problem that says divide hundredths by hundredths. Well, you could totally do what we've been talking about. You could go use that math map, which is at the back of your notes packet, or there's also another method that we're going to show you today that lots of students seem to prefer. So method number 1, it says convert your decimals to fractions. So I'm given some decimals, and they say I could rewrite it as fractions. If you know how to read this decimal, if you realize that that 56 lands in the hundredths place, you could write 56 hundredths. Next it says let's divide, so let's go ahead and record that division symbol. But it says let's divide by this decimal. Well, what place value is that 4 in? It's in the tenths hundredths. This is divided by 4 hundredths. Oh my goodness, this looks like something we've seen before. This looks like decimal, wrong thing. This looks like fraction division, doesn't it? So I remember that we can perform a keep, change, flip, also known as multiply by the reciprocal. So if I do that, I keep the first fraction, 56 hundredths. We change to the opposite of division, we make it multiplication. And a reciprocal, also known as the flip, looks like 100 over 4. This would be a great time to ask you, do you see any cross simplifying we might do? And I hope you notice, these hundreds really look familiar, don't they? What goes into 100 nicely? Maybe you say 2. That's nice, but we're at the auction now. Maybe you say 4. 4 going once, going twice. How about 20? Oh, that's not bad. 20 going once, going twice. 25, even better. 50? Oh, someone says 100. In fact, we can divide both of these by 100. Their greatest common factor. Well, 100 goes into 100 one time, and 100 goes into this 100 one time. Notice I'm keeping those new numerators and denominators on the outside. Next, I'm going to look for some cross-simplifying going the other direction. 56 and 4, do they share any common factors? Well, they're definitely both even, so I could divide them both by 2. But is there anything else? Maybe you notice that they are both even, but they both divide by 4. So let's go ahead and divide both of these by their greatest common factor, the 4 that they both have in common. Well, 4 goes into 4 one time. I keep that one on the outside. And 4 goes into 56. That's kind of like 40 plus 16, isn't it? Well, it goes into 40 10 times, and it goes into 16 4 times. So I'm going to get 14. Let's go ahead and multiply across. Well, 14 times 1 gets me 14, and 1 times 1 on the bottom gets me 1 in the denominator. If you remember, this is the same as a whole number of 14. This is one method to approach your division of decimals. Now notice, it does sometimes get me some bigger numbers. So for some reasons, it might not be ideal. In some situations, we might want to try method 2 instead. Method 2 is that long division, moving that decimal. I like to call it Simon Says, or maybe Schumann Says, because that sounds cool. Okay, so let's go ahead and set up our problem. The first number I'm given becomes my dividend. It dives in, 0 and 56 hundredths. The second number I'm given is called my divisor. It always is on the outside supervising. And sometimes I like to call him Simon or Schumann. So for that reason, the divisor tells us how many hops to make. We need to multiply by 10 and by 10 again. We're multiplying this number by 100. Simon says, swoop to the right twice. And if Simon says swoop to the right twice, you'll want to win the game. Swoop to the right twice. My new decimal location is behind the 56. If I do a quick rewrite step to clean this up for you, I now have a whole number of 4 divided into 56. Well, I think it goes in there a nice number of times, but we'll check it out taking it in steps. 4 goes into 5 once, because 1 times 4 is 4. When I subtract, there's 1 remaining, and I'll bring down the next place value. 4 goes into 16 4 times, because 4 times 4 is 16. And when you subtract, there's nothing left. If you take a look, I got the same great answer as I had a minute ago. 14 will work for both of them. So again, we have some options. If you're fighting with Simon Says, Schumann Says, you could definitely try converting your decimals to fractions. I would just caution you that sometimes when we're simplifying, this cross-simplifying idea, if we don't end up with nice denominators, sometimes it's hard to see a final answer in decimal form. With that, I'm going to stop our video here. I'm going to hope that you have enough to go on so that you can be successful with your assignment from lesson 3.3, dividing decimals.